Okay, for this chapter, I will try to cover in the theory first, and then if we have no time, we will discuss on Monday night for the Excel, how to do your Excel. Alright, so we will cover to this week. Today we will cover to until 3.3 inference for single population. And then we have here is the main here is step in hypothesis testing for population mean, and hypothesis testing for population proportion. So we have two different there. Okay. Yes.
Tahu ke?
Ya.
Doktor tak present saya rasa.
Saya rasa macam saya tak tekan. Saya tak tekan. Okay, sorry. Dah, settle. Belum. Dah present. Okay, interaction. So we have 3. So So here we can see we will end until 3.3 here. Hypothesis. We have hypothesis testing for the population mean and hypothesis testing for proportion. Okay. So what is the difference here? Means is refer to what? Proportion is refer to what? So if you can see in your textbook, we will have this thing. We have a population, and then we have sample, and then statistical inference is the is depends on the is the sample from if we make the inference from the sample. So this is actually chapter 1. In chapter 1 we already did, but this more detail, which is the population is about the whole data set we have, but sample is from the whole data set. What we get the sample? We take the sample because why we take the sample? Why we take the sample? Why we take the sample? Save time? No, not not that purpose. Why we take the sample? To draw conclusion. Macam terkena tiang. Tak goal lah, maksudnya tak goal. Betul tapi tak goal. Yang pasti dia tak goal. Dia terkena tiang saja. Why we need a sampling? Why we make a sampling? Okay, boleh cuba. Salah tak apa kat exam pun. To collect data. No. Betul kita collect data. Tapi dia tak menjawab why is we need the sampling. Tak ada jawapan. Why we need sampling? Collect data. Salah. Konsep ni pun dah salah tu. Why actually we study statistics? Usually always say about sampling, population. Why? Why we always make a sampling? Even in your experiment, you take a sampling. Ni macam lebih dapat lah to extract useful information from the population or to investigate something. Because if we want, we do not go through the whole sampling to make experiment, right? Because we just want to test and make an inference. So from that sample, we can predict it, project it into a general conclusion. So it depend on the objective of the sampling to collect a data, to get information, or to predict something, or to see a trend. So that is the whole story. Why? That's why we always use a sampling. But in a real thing, sometimes the data set that we get is give the whole picture for the population. But if a sample, so we just take a random sample from the whole picture, which is, but from that way we also can give a inference. So if you go here, we can see the difference between parameter and statistic. Okay, parameter is a numerical a number measure that describe a population, but statistic is a numerical measure that describe a sample. So means new. We see that means new and the population proportion P are parameter, but for the sample we denote as a X bar, and the sample proportion is P hat statistic. Okay, so okay, and then a statistic is known and compute from sample, estimator for a parameter, and true value of parameter is unknown, and estimate for the sample data. So this is the whole picture lah. The whole picture, we have a population, and then we take a sample, random sample, and then we calculate the numerical measurement, and then we have a sample statistic, and then we estimate the parameter. We estimate the parameter for the population, and we draw the conclusion. So we can see here, parameter estimation, we have two different between parameter estimation and hypothesis testing. So we can highlight here this thing you should highlight, which is parameter is estimate population mean lifetime using the sample mean of lifetime, and for the hypothesis is sample evidence, which is we test and then we claim for the population. Okay, clear here? Clear? Sample distribution. So we have a sample distribution. So if we can read here, a sample distribution is a distribution for all possible value of the sample statistic measure on a repeated random samples of each size and drawn from the population of interest. So we can see here we have the whole sample, and then we can make is first sample, second sample until up to 100 sample. It depends lah. Okay, it depend berapa yang you nak ambil as a sample. Okay, and then later on we will learn how to what to make how many sample that is good for the population to predict or to make a testing. So this is a sample mean and difference between sample mean and sample proportion. So we have mean and proportion. So the proportion of interest is normally distributed for the mean, and the distribution of the sample mean will be normally distributed regardless of the sample size. And for the sample proportion, so we have n greater or equals to 10 and q is greater or equal to 10, and this sample proportion will be approximately normal. Okay, approximately distributed. Approximately distributed. Here is sample mean will be normally distributed. Sample mean will be normally distributed. Normally distributed, but here is approximately distributed. Okay, you see the difference? You see the difference here. Okay, center of distribution of sample mean is a given population mean. We have this. But for the proportion, we have UP equals to P. Spread, standard deviation for the distribution of sample mean is given by this. For the proportion, we have this. So this is the difference lah between means and proportion. Okay, relationship between distribution and sample distribution, we have center for the both distribution is same. Dispersion for sampling distribution is narrower than population distribution. According to the central limit theorem, if population distribution is not normal, okay, is not normal distribute, and the sample size is sufficiently large, the sampling distribution will be approximately normal regardless the shape of population. So dia punya teori lah. We have central limit theorem. So this central limit theorem. So we said that if all sample size certain size are drawn from any population, the sample distribution is a sample statistic is an approximately a normal distribution. So they approximate je lah. They approximate normal distribution. This approximate improve the larger sample size. So similar sample size, larger sample size. So macam kita draw before this, if we take more sample, more n, so the graph will be normal, something like that. So that's why we can use this theorem lah to approximately the normal distribution. Okay, inference for single population. So we need to make inference for the single population. Later on we have for two population, how to make inference. Two proportion and two inference for two population later on. The next week we'll discuss on two population, but for this week only one single population, only one. So we always have a two different, which is we have point estimation, interval estimation. What is a point estimation? A single value estimate for unknown population parameter, but for interval estimation we have interval estimation is range of the value to estimate the population here. So here is the point is a point itself. So we have only a dot here. So we have a point estimation, but in for this point we have the interval of estimation. So estimation is a method to estimate unknown population parameter for a sample drawn from the population. So here we have a range. We have a margin error here. Right? We have a margin error here. We can see here there is a difference between the interval, the lower interval, and between the point, and then the upper interval. So this is, we call it as a error, margin error here. So what this give us? This will give us this, a margin error, lower confidence interval, and then there is a upper confidence interval, which is we call it as a CI, the white of the confidence interval. That's why we can see our confidence interval, we will discuss on 90% confidence interval, 95% confidence interval, and 99% confidence interval. Meaning, if the 99% confidence interval, so meaning it is very close to this interval. So the difference is the wide of the interval that cover the margin of error here. Okay. Okay, so example of the point estimation, they have example here. Example mean okay. So we have unknown parameter, point estimation, interval estimation. So if we have unknown of mean here for parameter, and then we have estimation. Estimation we put bar at mean tu. And then for interval estimation we put maybe PQ is refer to any number, any interval that represent in this estimation lah. And then P also the similar. And if we have two mean, so we have like this interval estimation, but if we have two proportion, we have like this proportion interval estimation. So the difference is, if a point estimation we just a single without this less this symbol, less this symbol. Okay, these two symbol they come always with two symbol. So the confidence interval and the margin error. So here the same thing we discuss on confidence interval alpha 0.1, 0.05, 0.01. So the critical value of this value is here. So we can see from the table at the back of your book. Okay. Confidence interval CI allows us to estimate the actual value of unknown parameter with a certain confidence interval. So we can estimate lah based on what is the confidence interval that we choose lah. We need to choose. Or if in your examination, they already state what the confidence interval that you want to choose. Okay, it's depend. That is not fixed lah. It fits if already stated. Okay. Okay, when we repeatedly sample from the population, there is always variability between sample. Thus, the amount of acceptable difference from the actual population can be quantified through confidence level and margin error. So, confidence interval, we have known and unknown data. So, there is a difference between known and unknown data. So, for known data, we use this formula to find the interval. Okay, we know that we have a point interval. So, to find this value, before this we put as a P and Q. So, we use this formula. For unknown data and greater or equal to 30, so you use this formula. But for less than 30, we use this formula. But we need to know V. V is a number of freedom. Okay. Okay, N is a sample size. S bar is mean, sample mean. And then we have S over square root of N, or sigma over square root of N, which is referred to standard error of the sample mean. Z over alpha, Z alpha over 2, critical value based on the standard normal distribution, and T alpha over 2 is a critical value of the student based on standard T salah ni. Based on standard T distribution with degree of freedom V. So dia ada salah kan? Standard, a critical value based on standard T distribution with degree of freedom V. So dia tulis student. Okay, itu salah distribution kat sini. Alright. So next. Okay, this is example. So we can see the example. We have N is 20 student from the population. So maybe it takes sample N 20 student with known standard deviation. So known data. So known data meaning we have a known data. So this formula. Okay, this formula. Known data. And then based on the sample data, it is found that the mean of student weight in kilogram is this. And interpret the 95% confidence interval for the population mean nu of if sigma is 15. So this question want to construct the confidence interval. So we need to find the lower value than the upper value for nu. So S bar is 64.3. So Z alpha over 2 is 1.96. And then we have sigma 15. N is square root of N is a sample size, so square root of 20. So we will have 57.73. between 57.73 and 70.87. So this is the interval that ni, so we can construct a sentence here. We are 95 confident that the mean weight of all students is between 7.73 and 70.87 kilogram. So my question here is where you get 1.96 here? Where you get? How you get this? Okay, how you get this? Fatini Husna, how you get 1.96? Macam mana dapat?
Ya, doktor?
Macam mana kita boleh dapat Z alpha over 2 tu sebab as a 1.96 tu? Kenapa dia letak 1.96 kat situ?
Soalan dekat skrin ya, doktor?
Soalan dekat skrin, dekat buku page 93. Why? Macam mana dapat 1.96?
Dekat
Ya. Macam mana?
dekat table.
Dekat table. Daripada table standard table kat belakang buku kan. At your back of your book. At the back of the book we can see.
Dekat belakang buku.
Yes. But actually dia dah bagi tahu kat sini. So dia bagi tahu kat sini 95% confident interval. So kat sini dia dah keluarkan lah, you tak perlu refer kat belakang buku lah. So 95% of interval, so critical value of Z alpha over 2 is 1.96. If benda ni tak ada, you boleh refer je kat belakang buku. Okay, kat belakang buku 0.02. Kat belakang buku kita tengok 0.02 alpha T distribution 0.05 kan. Zero point zero five. One point 96. Okay. 0.05. Daripada table kat belakang lah, you boleh tengok table kat belakang. Ya, saya tengah cari ni satu point. You all jumpa tak 1.96 tu? So alpha is 0.05. Alpha is 0.05. 0.05. Siapa yang dah jumpa? Jumpa tak kat belakang tu? Ya, macam mana tu? Saya tak jumpa. Sekejap. Kat mana siapa ni? 0.09.
Muka surat 239 tu, doktor?
239 kan? 239. 0.05.
Maksud doktor 1.96 tu cari kat tengah-tengah tu ke, doktor?
You dapat cari tak? Kat mana 1.9 tu?
1.96 saya jumpa dekat 0.025.
0.025. Betul. 0.025. Kenapa dia jadi 0.025?
After divide 0.05 with 2.
Ya. Patut saya tak jumpa tadi. Alright. Bagus. You all lagi bagus. Alright, good. Okay, kalau tengok kan kat belakang ni. Standard normal distribution. So, kita ambil 0.025. So, 0.025. Kita ada 1.96 ni. 1.96, okay? Okay, kat situ. Kenapa kita divide by 2? Because of this. Lama. Kat sini dia dah tulis dah. Saya tak tengok kat sini. Duk mencari. Okay, so we divide by 2. So we have this area. So once we identify this area, once we identify that area, we go to the back of your book, and then we can see the value of 1.96, or easily you can use from this table lah. They already put it here. Alright, so I hope you understood what is discussed here. So for here, there is another example. So we have a researcher conduct a survey to determine the mean waiting time for a treatment emergency room from the several government hospital, and then for a random sample 30. So what is 30 here? 30 is an emergency room. It is found that a sample mean waiting is, so this is S bar. Then the standard deviation of here is so this is a sigma. This is S. Salah. This is S. Alright, and then calculate the point of estimation. We want a point of estimation and interval of estimation with the 91 confident interval. So 91 confident interval, we actually is 0 point what? So 0.01, right? 0.01. So 0.01 divided by 2, we will have 0.005, which is equals to 0.15%. Okay. So kat sini, so we have this thing. So to find CA, so we have this formula. Okay, see, we have this formula. We have this formula. This is unknown data. We have unknown data, so we use this formula. Okay, because the sample is n is greater or equals to 30. Just meet the requirement lah. If less than 30, so this is greater and equals to 30. So we can use that formula. But if less, so you need another formula. Then after that, we put everything inside here. Then we get the confidence interval, and then you make a conclusion here. The conclusion is 99% confident that the mean waiting time for a treatment at the emergency room is between this and this minute. Okay. So first of all, to find the confidence interval, you need to identify the unknown or known data. And then for unknown data, we need to identify is greater or equals to 30 or less than 30. Okay. So because we need to use a different formula for different population that we need to meet. So confidence interval for proportion, we have this formula. So we have this formula. N is a sample size, number X is a number of unit which characteristic of interest in a sample X, and then P hat here is X over N. So sometimes we do not have a P value, so we have X value. So X over N, we will get the proportion, sample proportion of a characteristic of interest. Okay, let's go to the examples. Okay, we have P, a proportion of student limit for self-learning, and P hat a corresponding sample proportion. And then sample size is N 1,500. And then 600 of students are agree that they have a limit amount of a time self-learning. So construct interpret 95% confidence interval for the proportion of all students who had limit amount for the self-time learning. So now we have this information. So we have this information. So we need to define first 0.05 confidence interval area, and then we divide by 2. What we'll get? We will get 0.025. So 0.05, but actually you can just easily grab from the table that in front of this chapter. And then for proportion, you need to use this formula, X over N. So the the sample that 600 over n, the whole sample, so that you got the probability for the sample that student agree with the limit amount of the time, and then the rest is not agree lah. So after that, you use this formula is direct. After you have all information, you put in this formula, and then you get this, and as usual make a comparison. So from here, actually we can also construct for the 99% of confidence interval, so we can see what will happen here. So is it the so what do you observe? Apa yang kita boleh tengok? Kita boleh tengok the difference between the interval tu makin kurang ke makin is it the interval is increase or decrease? So one of the part lah you boleh observe what happen if you put 99% of confidence interval. Okay, mudah ke senang? Mudah ke senang? Mudah mudah je. Tak pening-pening kan? Dia tak pening-pening, dia just senang. Cuma you kena ingat, you need to identify first unknown and unknown data, and then you need for unknown data we need to identify again, is it n is greater or equals to 30 or less than 30. So and then you need to remember the formula. So as easy as that, and then make sure you from the question you can grab what is the idea, what is the information inside there. So that I already highlight here, it is very important to you to see, because we will use this formula in this formula, even though here we cannot even though they already give information, but we cannot use directly. Okay, so next is we go the next level up. So try make it simple, as sweet and simple, so that you're not very trouble in understanding of this subject. So next is the determining sample size for estimation population mean and proportion. So how to determine the sample size to estimate the population mean and proportion? So we have this formula. So estimation for new and estimation for P. So we have this two formula. So E is a margin of error, and then population sigma is population standard deviation. So the difference is here. The difference is P hat and sigma. Okay, here we use a P hat, here we use a sigma. If sigma is unknown, estimate using S. Okay, so we do not really clear here, so we go to the example. So we have example here. A researcher wishes to estimate the actual mean depth of a river. For this purpose, he chose 99% confidence intervals. So 99% of confidence interval meaning 0.01. So we divide by 2, 0. Divide by 2, so 0.025. Zero point zero, sorry, 0.005. 0.005. Okay, which is Z alpha equals to apa tu? 0.01 2.5758. Okay, so this formula we want to use what formula? So we have these two formula. We have two formula. Okay, and then E equals to 2 to fit. Sample is to fit. To fit around the point estimate, and then the previous study know the standard deviation is 4.33. So sigma is known from the previous study, and then Z alpha equal to this ini, and then hence we use this formula. Z alpha is this, and then 4.33 is a standard deviation over 2, and then square all the value here, and then we got 31.1. So wait, so round up the value from 31.1 to 32. Thus he need at least a sample of 32 measurement to be 99% confident interval. So from here, so this is the process how to find the good sample based on the confident interval that we want to choose. Okay, if we want to choose 95% of confident interval, so the sample size would be different lah. Okay, it would be different because the Z value here is different. So the Z value is different here. Okay, there is another example. So what is the how many sample that we need to make the confident interval is 95% confident. So we want 95% confident interval. So 95% is 0 point, ya Allah teruknya, 0.05. Okay, and then you divide by 2. This is a normal, but you just use from the table. So 0.05 we have 0.05 1.96. Okay, 1.96 here, and then hence this is for proportion. So okay, 45% interview student had personal notebook and calculate the sample size required for the estimation. Who own a personal book or not? Okay, so 0.4, 0.5 because of this P hat. Here is 1 over P hat. Then this is 1.6. 1.6 is Z alpha over 2, and then this is E. Then we have estimation of the sample size, and then we need to round off here. Why we need to round off? 2305. Why we need to round off? Kenapa perlu bundarkan? Kenapa kita perlu bundarkan? Kenapa kita perlu bundarkan? Suhail Azmin, sebab student. Salah, bukan sebab student tu. Yang sebelum ni pun kita round off. Kenapa round off? Kenapa yang sebelum ni kita round off juga? To obtain the whole number. Kenapa kita nak the whole number? Why we need a whole number? Kita tak nak decimal. Kenapa kita tak nak decimal kat sini? Value tu kenapa kita tak nak decimal? Kat sini pun kita round up. Kenapa? Dia bukan round off, dia round up. Dia naikkan satu. Kenapa dia naikkan satu tu? Yang ni kebetulan 0.9 kan. Kenapa dia round up? To obtain the whole number. Why important of the whole number? Kenapa dia round up? Bukan maksud round off ni. Maksudnya dia round up. Dia akan tambah nombor integer yang seterusnya. The next number integer. Why round up? Secara logik lah. If you use your logic. Sebab discrete. Betul, sebab discrete. Apa yang discrete? What is this discrete that you refer to? Sample tu. Yes, because of that sample tu we round up. So that no issue lah. So we add extra one so that the whole. So kalau if the number of sample if we have a decimal, so how we can take the sample size? So by hook by crook we need the whole number so that we can take the number of sample. How many number of sample we want? Something like that. And we round up because if we extra is okay, but if we less is maybe it will make reduce our assumption tadi, because we want to make a assumption. Okay, I think we rest 5 minutes here. And then we continue again for the introduction to the hypothesis testing. Okay, boleh?
Boleh, doktor.